right. All right, can everybody see that?
Yes.
All right, great. So yeah, welcome everybody. I'm Alana. This is Deep Learning Adventures, a collaborative community, semi-famously known for being fun and engaging, among other things. And the focus today will be a presentation by Svetlana Levitan, who's joining us from Chicago, and she'll talk for us about open standards and open source projects related to those, their applications, and how to get involved. So firstly, for those of you new to the group, the Deep Learning Meetup site has a collection of resources, with links to join the Slack channel, a link to the GitHub repo for code, and to the YouTube recordings from the past, basically organized by these three main topics. The first one there, the Deep Learning TF, is from when the group went through the TensorFlow and Practice certification course together. So that's a pretty cool resource if you're thinking about doing that yourself. And the second one is, there's 5 recordings there from previous coding challenges that people did together, which is also pretty helpful. And I'll just do a quick run through of what those are a little bit later. And the last category is from when the group has guest speakers join, like today. So this will be, I think, the 3rd one in that group. So that's also pretty cool. And then just a heartfelt shout out to 3 meetups from Chicago that cross-posted this event for today. Chicago ML Big Data Developers in Chicago, and Open Source Analytics Chicago. And I think we're going to have some representatives from those meetups maybe hop on a little bit later and tell us more about themselves. So that'll be cool to get to know each other. And then just a moment to recognize TensorFlow, the framework that I'm sure a lot of us are aware of is pretty helpful for kind of any deep learning project, neural networks, GANs, NLP, what have you. And the Setup Colab, also really helpful, widely used for many reasons, and it's free. So anyone can use it for the cloud computing and just, have at it with any project that they want to try to tackle. And speaking of specific projects, there were 5 kind of in that YouTube recording bit.ly channel that I mentioned earlier that this group did together. One of them, the first one, was a computer vision about classifying diseases in plants. And the second one, well, this is just an annotation exercise, but it's also pretty fun, so you should check it out. And NLP with the TV show Friends. And then a structured data set challenge that had the big issue there was like unbalanced classes, so that's fun. And also, just like a note with these, it's pretty cool to go back and watch these because there are 4 actually, mainly from the group, that complete notebooks and give walkthroughs, and the different approaches are pretty informative. So we all appreciate that. And then the last one is a time series with weather data. So check those out. And then just kind of a quick recap here on the meetup page that, you're welcome to join the Slack channel, check out the GitHub repos, and then the recordings organized in those 3 categories. And then I'll pass the ball back to George here for the moment. We're going to try something kind of new here because it's great that more people are joining, and that just makes it a little bit harder to kind of do the roundtable thing and go around and introduce yourselves. So go ahead, George.
Thank you, Alana. Thank you. And before we do this exercise, it's a new pilot program for us as well. But I'd like to welcome Svetlana and some of the organizers of the other meetups, and give them a chance to introduce themselves and say a few words about their meetups and their community. I really love when 2 different communities come together and get to know each other better.
Thank you very much, George, for letting us join you today. Gareth, do you want to say something about Chicago ML?
Okay, anyway, hello. Nice to meet everyone. Of course, one of the downsides is we have to meet on Zoom. One of the upsides is we can meet everyone from around the world. So that's pretty cool. I hope we actually continue doing this once we get some semblance of normalcy here. It's fun to meet people from all over. I co-organized Chicago ML with Svetlana and a couple other organizers. And we are just general purpose machine learning, and we have talks that cover technical sides and research, software tooling, I guess that there are probably a few people from a group on the meetup. So hello and welcome. And if you're in Chicago, you're probably already a part of the meetup, so I don't have to pitch anything. So I'm basically just going to say hello and welcome to everybody.
Thank you. And Mary?
Sure. Hello. Yeah, my name is Mary Grigleski. I'm a Java developer advocate at IBM, actually. And I also help to run a bunch of meetup groups, including I'm president of Chicago Java Users Group. I'm less of a machine learning or data science person, but although I've kind of started also looking into studying those and also did some talk too on that, in fact. So I worked with Svetlana at IBM. So I'd just like to quickly share one thing is actually inviting you to sign up for the IBM Cloud. It's all free. You don't need your credit card. And so let me kind of quickly, if that's okay, I'll just, while I'm talking, so then, so you can, maybe there's also a QR code too, if it's easier too for you. So if you sign up for that, it's and then I think Svetlana, you'll be talking about machine learning pipeline. So there's also Watson Studio, so you can actually take advantage of that too using inside the IBM Cloud. So so I'm very excited to be watching this Svetlana's presentation today. So and nice meeting you all. So
Nice meeting you too. Welcome, Garrett. Welcome, Mary. Welcome, everyone.
Thank you.
So I thought it would be a nice exercise for us to break out in different breakout rooms, getting to know each other better. I'll kick it off just to give you some training data set to work with. My name is George. I'm a regular member of this meetup, a founder and co-organizer along with my good friends David and Robert for joining us today, as well as great friends from all around the world who join us every week. I really enjoy meeting new people, building communities, and learning not only deep learning, but also machine learning tasks and new challenges. In terms of hobbies, I enjoy running and taking pictures, and I have 2 little guinea pigs. If you didn't notice, you join us as of now. They're live streaming on our Zoom channel here. So kudos to whoever gets the guinea pigs in the breakout room. So we'll have about 5 minutes, and I would love for us to mention, who we are, where we're from, probably, which part of the world, and what do we enjoy learning, and maybe some of our hobbies. I think that will get us a little bit closer to each other and get to know our communities better. So I'll kick it off. Let me stop sharing my screen. So it's 47, almost 50 of us. Let's do 10 rooms, 9 rooms. Okay. I'll be sending a broadcast message in 5 minutes just for you to allow you to come back, but you don't have to do anything. Just go around the table, unmute yourself, say a few words by yourself, and get to know each other better. So I'll see you in 5 minutes.
We have 300 megabit Ethernet, and collaborated on a few things already.
Are you professionally a deep learner?
Yeah, that's basically, I'm doing applied intelligence at Accenture Federal Services. So
Okay.
that's it's part of what I do. NLP. Even today, there's discussion about open ML pipelines, and so this presentation may be very helpful to expand my awareness as well. So looking forward to it.
I'm out in Aurora at the end of the BNSF line.
Uh-huh.
Just short train ride into the city.
With Intel, and my hobbies: running, gardening, hanging out with my grandkids and my kids and my husband. Next.
Sure. I'm Peter. I've been actually with this group since the beginning, although I haven't been able to make the last couple of meetups. Friday evenings were pretty easy back at the beginning of all this because
Hi, I'll go next. My name is Kiran. I'm here in Chicago suburb. I'm working to transition from academia to data science. I have like academic research experience. I have done Coursera certification and working on project and here and there in Kaggle competitions. And so I'm in the applying job for now, looking for a job.
Well, this is Osama. I work with the Johns Hopkins University in Maryland, and I've been doing machine learning with focus on cyber security application.
Oh, yeah. Oh, okay. George.
Yeah, Mary, I have one question.
Oh, I came back here. I just want to say hi, Mary. I'm here.
Cool.
Yeah. And so nice to meet you all. I'm sorry about that.
Yeah, nice to meet you, Shisha.
Actually, my name is Shakufa, but so I just put the abbreviation. Yeah.
Okay.
I'm sorry. And make it somehow interesting. So I started machine learning actually more. So I'm still beginner, although I am learning.
They're still doing Google scripting, so.
Wow, amazing.
All right, what about Mark over there?
Yeah, can you hear me okay?
Yes.
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 Well, I would say that I'm a new and maybe a regular. I've been to 3 meetings as far as the group goes. And with data science, I'm still on the outside looking in. Started my career as an electrical engineer. I've done programming. I've been an entrepreneur for a number of years. And now I'm in a systems engineering kind of role. I've been a director as well in one of the steps in between. So I'm just curious about learning new things and combining different skill sets that I have, and found that George, you're running a great group here to help accelerate that. So
awesome. Good to see you again, Mark. Thank you.
Yeah.
All right, so we have Juba down there. Oh, no microphone.
No microphone.
Yeah.
Cool. Okay, let me stop by.
Maybe you could type in the chat, Chuba.
Yeah, you can use chat.
Yeah. How many guinea pigs do you have? That's what we want to know.
2. I'm still waiting to join the room that has the guinea pig. This is breakout room 6. It's the 7th one, 8th one. I don't know. I'll let you know.
It's like a treasure hunt. It's so cool.
Exactly.
How old are they?
1.5 years old.
How long do they live?
8, 9 years.
Nice.
So new. Let me join 2 more rooms, friends, and I'll be bringing back everybody to the main room, okay?
Sure.
Okay, thank you.
Hi, George.
How's it going?
Okay.
Really cool.
Everybody introduce themselves and make some new friends.
Yeah, you know, Jürgen is from Peru too.
Oh, really? What a small world.
I know, right?
What a small world. Tell me some places in Peru so I can tell my roommate, because my roommate is from Peru. She's from there. So tell me some places I can tell you from.
You know where I'm from, Piura.
Hold on, let me write it down. Wait.
Where are you from, Jürgen?
Lima, but I've been to Piura several times. Love
Lima?
Mancora,
Piura?
everywhere, yeah.
P-U-D-A, is that how you spell it?
P-I-U-R-U-R-A.
Oh, Piura.
Piura.
And Lima, you said, right?
Yep.
What about you, Dan? Where are you from? Joining us today?
I'm from Chicago.
Cool. Welcome. Welcome.
I was saying to them, I had just joined the Chicago ML group But then my friend Liana also told me that I should join the Deep Learning Adventures.
Awesome.
So
2 for 1.
Both groups.
Yep, you get 2 groups for the with the opportunity of 1 here. Awesome. And Katerina, are you joining us from somewhere? Big. Welcome, Katerina. We welcome you anyway. All right, friends. Let me try and bring us everybody back home. Okay, give me a second.
Just to give you a bit of background, done basically in my master's more of a data intensive computing, and somewhere during my master's I realized, oh, machine learning is important for my internship, so I took machine learning, and somewhere that rabbit hole made me realize that, oh, these are all just pattern recognition and advanced statistics at one point of time. So I got crazy a bit after my master's. I was like, oh, I got to study more. So I did a self-driving course and finished
You're
that in a
hooked.
year. Yeah, I'm kind of hooked. Then I did that. Then I realized, okay, the only thing is like right now in my current work, I have a lot of tooling based and maybe big data and other stuff related. So sometimes I feel like maybe it's a good time to understand the other side of the data science aspect also. So, or machine learning to be very precise. So just trying out my hand in that. That's me. I cycle for time pass.
Did everybody introduce themselves and make some new friends?
Yeah.
Including our guinea pigs here.
5 whole minutes.
Cool. All right. This is fun. I'll be bringing us to the main session, everyone. Thanks.
Hey, George, is it Qubit? Do you pronounce his name Qubit?
Qubit and butter.
Qubit and butter.
Qubit is black and white, and she's like a quantum particle. Butter is the brown one. She's just spoiled and smooth, like butter. Come on, Qubit.
Oh, so
come on
funny.
up, girl. Come on up. They don't come up.
You're on mute.
They're too skeptical.
They're on mute. Oh, see you in there.
All right, friends. I'll see you in the main session.
See you then.
Conclusion news.
All right. We have a few more people coming back from the breakout rooms. What did you think? I hope you enjoyed that session. It brings us a little bit closer, I think, and gets to know each other better. Thumbs up. Awesome.
Thank you.
Yeah, it was fun. Svetlana, I'll hand it over to you. Feel free to share your screen and start with your presentation. I just want to welcome you again and thank you very much for being here with us tonight and sharing some great work that hopefully we can learn something and take away with us. We can see a beautiful tree and a clear sky. Looks like you're extending.
Sorry, let me start my presentation.
You don't mind looking at that, it's beautiful.
That's just a standard Windows picture.
I was about to say, is that your backyard?
Wow. Okay. Somehow it looks a little different, but okay.
We can see your presentation now.
Yeah, so thank you all very much for letting me present and for coming to this presentation. And I apologize to Jewish people that apparently today is beginning of Rosh Hashanah and I didn't realize it before. So Happy New Year to those who celebrate. A little bit about myself. I came to the United States from Moscow, Russia, long time ago. And I came for graduate study and I studied at University of Maryland, College Park, which is very close to Washington, D.C. And
great school.
I was in
great school.
Yes. So I was in a PhD program for applied math. And I also liked, well, as part of the program, I was required to take some computer science courses, but I also liked them a lot and I took many more. And then I asked them, can I also get masters in computer science? And they said, no. And then I said, okay. And then I thought about it and I said again, you know what, I want you to allow that, because when I applied to graduate schools, I noticed that, for example, Cornell University had this joint program where people getting PhD in math could also get masters in computer science, because there was a pretty bad job situation for math PhDs. So anyway, I went to the graduate school with this proposal to allow this joint program for masters in computer science and PhD in applied math, and finally they agreed. So I got both. I did take a lot of courses in computer science anyway.
So Svetlana, you're probably friends with Sergey Brin, is that right?
No, I'm not friends with him. When I was a student at the University of Maryland, his father, Michael Brin, was a professor at the math department. And Sergey was already gone from Maryland.
Well, pretty close, close enough.
Yeah, so I did know Michael Brin. Later, he donated several million to the university because he got very rich with Google stock. He is retired now, of course. That was a while ago. Anyway, so after that, we moved to Chicago. After my husband and I got our PhDs at Maryland, we moved to Chicago because he had a postdoc at Northwestern University. And then I joined SPSS, which was a statistical software company. And I was working on implementing statistical and machine learning algorithms for SPSS for 18 years. And I was often wondering how are those algorithms used in practice, but I didn't get too much experience with these practical applications, even though I wanted to. And also I was working on PMML, which is an open standard, and I will tell you about it today. And then 2 years ago, there was some reorganization, and I became a developer advocate at IBM with a group called CodeA, Center for Open Source Data and AI Technologies. And I enjoyed that position for about 2 years. And I worked with Mary, who you met today, because she just joined IBM about that time as a developer advocate too. So we worked together, organized many meetups, and did conferences, etc. And then, well, this summer there was another reorganization, after which I was free to work with a little startup as a data scientist. And that's what I'm doing now, although it's a kind of volunteer position. So now I'm open for a new full-time position, preferably in data science, but as a software engineer could also work. Well, as long as it works with machine learning, I think. Yeah, and that's enough about me. So today we are going to talk about the following things. First, we'll talk a little bit about machine learning process in general and what is a machine learning pipeline. And then we'll talk about those open standards that I promised. And then we'll talk about related open source libraries. And of course, if you have any questions, don't hesitate to ask anytime. I'm not sure if I can see the chat, but you can just unmute yourself and ask if you want something. But please keep yourself muted if you are not asking questions, so that we don't get too much noise, okay?
Sorry, Svetlana, feel free to post your questions on the chat. I'll be monitoring the chat.
Okay, yeah, sounds good, thank you. Yeah, so what's machine learning? According to Wikipedia, it's a study of computer algorithms that improve automatically through experience. And basically what happens is if you have a machine learning algorithm, you throw a bunch of data on it, and hopefully it will figure out how to do something without being explicitly programmed to do so, right? And machine learning is not just, okay, you take your data and you build a model and you're done. It's a whole process. Because first of all, especially in, well, maybe if you are in a Kaggle competition, that's all you do. You just get your data and you build a model and you're done. But even with Kaggle competition, you have to prepare your data and do feature engineering, etc. So in general, in real life situations, first you have to collect the data, maybe find different data sources with different kinds of data and ways to combine those together and maybe reshape clean, prepare, transform your data, and then you build a model. Well, you probably build a bunch of models and then finally find a good one. So once you do that, you have a very good model with data preparation steps that seems to be working well. Then you need to deploy this model and the whole pipeline. So the transformations plus the model into some production system where you get predictions for new cases based on the model, and that's how you get your return on investment. And once you have deployed the model, you still need to monitor it and update, because with time, a very good model may become not so good anymore because trends in the data change. And depending on applications, that time could be pretty long or could be pretty short. So sometimes you need to update models very often. And when you need to update it, then what? You get more data and then you repeat the whole cycle. So today, our focus is this piece about model deployment. And we want it to be simple and fast because of all these other parts. And it needs to, of course, include not just the model, but preparation steps as well. So this is called machine learning pipeline, where this is a slide that was prepared by my colleague, Nick. I think it gives everything that we need. So the pipeline includes data sourcing, data transformations, feature preprocessing, then deep learning or machine learning model, and possibly some transformations that are applied to the predictions before they're actually used in practice. And here is a little example of how a machine learning pipeline looks in Watson Studio, which is a product of IBM, which is on IBM Cloud, and where you can get this free account that Mary talked about. So in this case, we have these two purple circles that represent data sources, and then those blue hexagons describe various transforms to the data, and here the two of those things are merged, and then there are models. And once you run this pipeline, so basically it's this drag and drop interface. You don't need to do any coding. And then when you run this, you get the model nugget. And from model nugget, you can get predictions for new cases. So if you have, yeah, this was inspired by the product which was originally called IBM SPSS Modeler. Well, originally it was actually called Clementine. It was a product that was created in the United Kingdom in the 90s. And then SPSS acquired that product, and then IBM acquired SPSS. Okay, so how do you actually create machine learning pipelines in practice? So Watson Studio was one of the examples, but of course there are many more ways. And right now, open source is very, very popular. And with open source, you can use Python and SKLearn if you're just doing some traditional machine learning, or there is TensorFlow, PyTorch, and a bunch of other deep learning frameworks, although others I think now are less popular. And there is this open source language R that you probably heard about. And with R, there is like 17,000 packages, if I'm not incorrect. And so you can do many things with R. And there is also Apache Spark, of course. And Apache Spark has lots of tools. And it's very good if you have very large distributed data. It has a lot of useful tools. And you can use Apache Spark MLlib using API in Scala, Python, Java, R. So there is a lot of varieties that you can use. In addition, there are those open source based products such as Vika, RapidMiner, H2O, NIME, and there are others. And there are commercial products, as I mentioned. My favorite is IBM SPSS Statistics. This was the original SPSS product that started back in 1968. And I worked for many years creating several features for this, several models for this product. And my husband is still working on this. And as I mentioned, there is Modeler and Watson Studio. And then SAS was always the main competitor of SPSS. And there was Salford Systems, which was a relatively small company, has been acquired by Meetup. And then there is MATLAB and Dataiku, and there are many DataRobot, many companies. So there are so many different tools where you can create those machine learning pipelines. And how do you deploy those pipelines? Well, many of those tools also have their own ways to deploy the models that you build with them. But in most cases, once you created a model in that tool, you can only deploy in the same tool. Well, with the exception of Docker. Well, Docker just allows you to deploy on other things, but then Docker itself, sometimes it works well, but sometimes it's not a convenient way to deploy. So that's why it is kind of important to have those open standards. With open standards, it doesn't matter where you create your model, you can deploy it into any other system. And that's how the idea of open standards works. So you get this easy ways to transfer models between different products, different programming environments, whatever. And the first such standard was, oh yeah, sorry, I just need one more slide here. Yeah, so why do we want to make those machine learning pipelines portable? Well, as I mentioned, so the models are built and pipelines are built by one team and then possibly deployed by a different team. And you may need to deploy them into different environments, such as into a database, or maybe into a web page, or maybe into some IoT device. So there are a variety of things places where you may need to deploy your model. And that's why those open standards are very helpful. And today we'll talk about the three standards: PML, PFA, and ONIX. And so back in 1990s, Professor Robert Grossman he was at University of Illinois in Chicago at that time. Now he is at University of Chicago, which is a much better university. He got an NSF grant to create this data mining group, the group of companies working together on the open standards for predictive model deployment. And the first such standard was PMML, Predictive Model Markup Language, which is a language, which is a standard for XML representation of models. And so it started back in the 90s. The first mention of it was in 1997 that we could find of. And I've been fortunate to work with it since about 2001. And since that time, this standard grew a lot, from the original like 6 models to now we have about 18 models in PML. And it is pretty widely supported in the industry by over 30 vendors and open source organizations. And you can find all the information about it at dmg.org/PMML. And this is a diagram that was found in one of those, in one of publications from Robert Grossman's group. This just shows PMML and PFA as ways to transfer those models from R or Pandas or SKLearn into all those possible application areas. And if we're talking about PMML, well, I'm sorry, I just like to talk about PML a lot. I worked with it for so long. So basically, PML is an XML document that has those 4 major parts. There is a required header that just describes your copyright and applications that created your model, or some information about that. Data dictionary describes the data that is used for model building. Transformation dictionary describes possible transformations. It is optional. And then there could be 1 or more models. And in terms of transformations, well, all the typical transformations that you would do to data probably are described, can be described by PML. In particular, there is a norm continuous, which is a piecewise linear transformation. There is norm discrete, which is a one-hot encoding. And then there is discretized map values, and there are built-in and user-defined functions and some other transformations. So pretty rich set of transformations, and it keeps growing. especially the set of built-in functions. And in PML 4.4, which is the latest, well, actually the latest is 4.4.1, but it's based on 4.4. We have 17 models listed here, plus a mining model, which is a way to combine several models together. If you want to create a model ensemble or model composition or a combination of those, you can use mining model. Yeah, you can see a list of models, which is, and in the release 4.4, which was relatively recently, we added a lot more into time series model, and if there is interest, I can talk about it later. I had a separate presentation just about the new features in time series model that I did at R in Finance conference last year. So in terms of PML models, inside each model, there is a mining schema, which describes what is your target, what are your predictors. Yeah, I should probably point out that PMML only works for structured data, right? So if you have unstructured data, PML unfortunately won't help you too much. But currently we are working on a way to represent deep learning model and images as inputs to PML. So that's in progress. Yeah, and then in a PML model, there are several optional elements. Outputs can be used to describe some post-processing of predictions. Model stats and model explanation do not really affect scoring, but they can be very useful for keeping additional model information so that you can use it PML for model visualization, not just for scoring, but also model visualization. And in SPSS products, we use it a lot. And then local transformations could be describing some transformations local to the model, which is useful if you have a bunch of models together in ensembles, and for each model you can have its own transformations. And then there is usually specific model content for different models that I will show you in a second. And model verification can provide you ways to actually give some examples of, okay, for these inputs, I get this prediction. And if your scoring engine doesn't give the same prediction with specified accuracy, then maybe your scoring engine won't work for my model. I think it is useful. I'm not sure how widely it is actually used. But at some point it was added because there was this company called MicroStrategy, which was very active in PML for several years, but then somehow they stopped participating. And they were concentrating on scoring PML models, and they wanted this model verification to be able to verify that they are doing it correctly. Okay, so some example PMLs. Here is a simple example of a logistic regression model. So you can see that the root element is PML, and then there is a header, and then there is data dictionary that says that we have continuous variable x1 and categorical variable y. And the categorical variable has categories yes and no. And then there is a regression model element that describes a regression model, which is classification model. And the mining field x1 is a predictor, because if you don't specify usage types, then by default it is a predictor. And y is a target. And then there is the intercept parameter and the coefficient for x1. So that's all you need to represent a logistic regression model, a simple one with just one predictor. Of course, if you have more predictors, the example gets longer, but you get the idea. So it's, I think it's very easy to read and very convenient representation. Now here I have a much longer example for a little neural network. So most of you probably already know what a neural network is. This is a little neural network built on IRIS dataset, which is a famous dataset found in this repository of datasets in University of California, Irvine. So there are 4 continuous measurements of iris flowers and 3 possible kinds of flowers. So this input layer on the left represents the 4 continuous predictors plus the bias. And then we have a hidden layer with 3 hidden units and a bias as well. And we have 3 units in the output layer because of 3 categories for the target variable. So data dictionary describes all these fields, as you can see here. And then in transformations, we have this norm discrete and norm continuous. So for the class variable, which is categorical, we need to use one hot encoding to match it to the 3 dummy fields that we need for outputs. And then for the continuous inputs, we need norm continuous, so we could normalize it to make sure that the values, input values are between -1 and 1 or something like that. And then in terms of neural network inputs, yeah, so neural network element is the model element for neural network. And then you see mining schema here, and then neural inputs, they describe how the input variables map to this nodes in the neural network. And then here we have part of hidden layer and the output layer. So basically everything is pretty clear how it's working. So as you know, in neural network, you have weights on the connections. So for each weight, there is an element con that describes from which neuron it comes and what is the weight. And as you can imagine, back when this model was created in PMML, which was sometime before 2000 or no later than in 2000, nobody was worried about deep learning then, right? If you imagine how to use this standard with a deep learning model, you may guess that it may be not so useful because it's just too wordy. And also there is no support for those special layers that are now widely used, like, you know, in CNN, convolutional layers, pooling layers, etc. Yeah, those are not here yet. But as I mentioned, currently we are working on adding new standard, new model kind that would describe a deep learning model. And if somebody is interested in helping me with that, that would be very good because we have some problems with that. So, okay, we'll talk about it later. So here is another example. This is example PML for a decision tree, again, built on this iris data. As you can see, this is a pretty simple decision tree. You have 2 binary splits, and one of them identifies those flowers of this first kind, which is, I cannot see, yeah, Iris setosa, and then the other 2 are more or less divided by this next comparison. So the data dictionary would be exactly the same as before, and then tree model, which is the model element here, includes a node element, which in turn includes other nodes if there are children of this node. And for each node, there is a predicate, which describes in which case you go to that child rather than that child. So in this case, simple predicate petal length less or equal 2.6 means that you go this way, otherwise you go the other way. And it says score distribution. In the score distribution, you have the counts of how many cases of each kind of flower goes into this node. And then this node number 2 has, in turn, has other nodes as its children. So as you can see, this information is sufficient for scoring a model and also sufficient for this visualization, which is very convenient. Now, in terms of practical applications, I remember, oh, and by the way, I think Yefim is here in this meeting, right, Yefim? So Yefim and I, at some point, worked on this POC with an insurance company. So there was this insurance company, they built a random forest model using R, and they exported PMML for it, and they wanted to do in-database scoring using in DB2 probably, I don't know, using IBM SPSS modeler in database scoring, which is very efficient. It just works inside database by user-defined function. And they had some problems because they were exporting PML 4.2 and our scoring code at that time did not yet support 4.2. So we worked to add support, and yeah, it was successful. So that's an example of practical application of PML. So you can build a model with one tool and then use PML to deploy into a totally different tool, and it works. Well, at least it should work if both tools are PML compliant to high enough degree. Okay, in terms of open source, there are several libraries which support PMML. And I think the biggest one is JPML library, which is created and maintained by a person in Estonia. I will show him later a little bit. So as Jay suggests, it is based on Java. And it has open source PML export for many models. SKLearn, SparkML, some of the R packages, and I think several other open source packages. There are many packages actually. And then there is scoring engine also, but that one is not completely free. You have to, I think you have to license it and pay something to use it for scoring. And then there is another package called Nyoka, which exports PML from SKLearn also. So it's kind of competing with JPML a little bit. And then there is R package PMML by people from Zementis. Zementis was a small company in San Diego, which now has been acquired by Software AG. And they created many open, well, I think they created Nyoka and this PML package in R. And why did they do this? Again, because they sell their scoring, PML scoring engine. So it makes sense for them to have people export their PML from various places, and then they would make money on scoring your PML for you. But then there is another package called PMML4S, which is a scoring, open source scoring package. 4S, it's in Scala, but then it has PyPML, which is a Python wrapper for it. And it is used in a product called Orange, which is one of the analytics products accepted to Linux Foundation AI group. Okay, now, so we're almost done with PML here, and the challenge now is, as I mentioned, now we are working on adding deep learning support, at least for convolutional neural networks. The problem is, how do we describe the outputs? Well, I'm kind of familiar with convolutional neural networks, I think, but I don't really, so if you just have a classification model, like if you want to classify which, if you have kinds of pictures with cats and dogs and you just want a classification, just regular classification, then it's clear how to represent that part of the output in PML, because it's just a regular classification model. But with those CNNs, you can also do object detection. With object detection, your output is much more complicated. Instead of just one result or maybe probability, cat or dog, now you have to return all those bounding boxes. So for each bounding box, you need at least 4 numbers, I think. Plus, so you have a bunch of them, and for each bounding box, you have those coordinates for it and size. Plus, you also need to say which object is contained in that bounding box and what is the probability of that. Right, so there is a lot of information that you need to somehow compute and return from the network. And there is another kind of result from CNN, which is image segmentation, where you have, okay, so for each pixel, you indicate which object it belongs to. So I imagine that the output, this kind of output would be, well, the size of it would be the same as the size of the whole picture, right? And then you also have to specify which color corresponds to which object. So how do we express this in PMML? I don't know. I would very much like to get help with that, because we need to finalize this. So that's an interesting question. So if you know those details, well, please get in touch with me and maybe we could collaborate on this part. because there is this proposal for deep learning from a guy who is a graduate student at Stanford, Max Ferguson. He has been working on this proposal for a while. But in terms of output, there is clearly a part that is missing, and he asked me to help with that part. And I'm not sure how to do that. So we need to work on this. Okay, any questions about PML so far?
Yeah, we had a couple of questions. Dimitri is asking, Dimitri, feel free to unmute yourself.
What is the question?
Oh, I'm sorry. Hi, Svetlana. Can you hear me?
Yes.
Yeah, my question was, if you're implementing a deep learning model, say in the image classification example that you brought, what would be the typical use case? Like, why would you need to implement PMML?
Yes, so, well, of course, now that there is ONNX, maybe we don't really need a PML. But in general, as I explained, PML is useful so that you can easily exchange models between different systems. And also, PMML is human readable, and that is very helpful. So if you give somebody a PML model, it's not a black box. Well, unless it's this kind of random forest with hundreds of trees of depth 10, then even though you can read it all, doesn't help you too much. But in general, it is a text format, so it is human readable, and that helps. Yeah. So those would be.
Can I clarify? So if you don't plan to transfer to another framework, like from TensorFlow to PyTorch or anything like that, if you just want to stay within one framework, are you saying we don't need any sort of this kind of language, PML or anything else?
All right. Yes. If you only want to stay within the same system, then you are good, I guess. I think okay.
Okay. Thank you.
I will thank you for the good question. Yes. When we talk about ONNX, maybe we should return to it a little bit, because I think the reason ONNX was actually created was because they had PyTorch that created models, but PyTorch did not provide good ways to deploy the models. With the TensorFlow, especially now, I heard there is a lot of different ways to deploy TensorFlow models, so Google is not interested in supporting any open standards. Yeah.
Svetlana, quick question. Because I was going to ask, so you take the PMML, is that run through an interpreter or a compiler? So in other words, to hit your target, so if you had like a AMD platform or ARM platform, you would otherwise have to cross-compile them, right? So does this take care of that for you?
Okay, so PMML is just a standard for representing models in XML. It does not actually have any code that does the prediction for you. There is some, that's why there are those scoring engines, and many of them like to charge money for doing scoring for you. Well, there is this free PML4S engine that doesn't charge you. But in general,
to clarify what I was asking, so like ONNX is a runtime. And
ONNX is not ONNX runtime. Yeah, ONNX runtime is a project which is open source project which is separate from ONNX standard.
Okay, but
yes.
if I'm running ONNX, I know that code targeted for that will run if I have the environment up, right? So is there an equivalent for PMML?
I don't think so. So you have to have a specific scoring engine to actually score PMML.
The thing is, if you think of machine learning as a function, the PMML is basically describing the function itself and the attributes, the inputs and outputs, the coefficient of the functions already contained in the PML file. So what happened is, whatever your framework is, once you get this information, all you need to do is the import, and automatically it should be easy. Your import function will basically create a function that basically represents a fitted model or a trained model. So that becomes it's much easier than compilation. Why would you need it? Well, one of them is the portability that the speaker talked about. Another thing also, if you're in a big company that have a lot of deployment of machine learning, you might get in a situation where your system, you have to upgrade. You have to move from one framework to another. Having a PML description, it becomes a click of a button, and you don't have to deal with legacy and all these issues that you deal with. So that's the advantage of a standard.
Yes, yes, I mentioned that. Thank you, that's a very good point. I mentioned that in the beginning, that when you need to update models, sometimes very often. So if you have PML, you just plug in a different XML file and you are done. You don't need to recompile anything, rebuild, retest. Yeah, that's one of the advantages of PML. Okay, so let's move on.
Hi, this is Pat. I had a question that
Okay.
I could throw out there. Do you know if it's possible to develop a model in a somewhat a traditional fashion, whether it's on your local laptop or in the cloud, but then deploy it to a mobile platform?
Yes. In terms of PMML or in general?
No, PMML.
With PML. Yeah, that's an excellent question. I think at some point I remember somebody at SPSS was trying to, so our scoring engine was in Java, and they tried to convert it into JavaScript so that it could be used where Java could not fit. And I don't think that succeeded. I don't know if there are, that's an excellent question. We need to find out if there are any open source packages that actually do this PML scoring on something small. If not, then it could be a good open source project to work on.
Okay, thank you.
Hi, Svetlana. I had a question about the convolutional neural networks that you mentioned were kind of a missing point so far in PMML.
Mm-hmm.
It seems like one could, for inference purposes only, one could represent a convolutional network, very inefficiently, but representing it as if it's a fully connected network and recalculating the weights that would result in that way. Has anyone done this, or is this just?
I don't think it would be very practical. That would be huge.
Not so practical, perhaps. Yeah, that might be what I'm getting at.
And then, yeah, the scoring engine would probably be very slow because it would not realize how it should work.
Well, I think the computation would probably take the same amount of time, but it would just take a lot of space to store the model.
Wait a moment. So, okay, the convolutional layer, okay, maybe you could represent it as a dense layer, but or feed-forward network. But then, how do you do the pooling layer? I don't think you can with current PML.
Yeah, maybe like a max pooling wouldn't work well.
Because we did, yeah, right, yeah. If you have average pooling, that's okay. With max pooling, I'm not sure. Probably.
The idea is to implement a standard specifically for CNNs.
Mm-hmm.
And I assume you may have similar challenges with LSTMs or transformer models or other more newer.
Well, I believe they were trying. So you see, NIST, National Institute of Standards, you know it, right? It's in Maryland. They are part of the data mining group, and they are working with a professor at Stanford and his graduate student Max to do this. And so far, they only tried to concentrate on CNN, but even with that, there are still many problems. So the challenge with PML is not very many people are actually working on it. Very few people are. And that's why it's moving pretty slow nowadays. So when we get to Onyx, you will see there are hundreds of people working. With PMML, there are just few, less than 10.
Mm.
And that's why there is, it moves pretty slow nowadays.
Right, thank you.
Used to be many more, but yeah.
Can I ask a question regarding you were asking about ideas for the PMML. Is it possible that you add another element that you have classification, which is a type of model, then you have the segmentation and the detection. If you add those, then you can basically define that the output will be either a rectangle or maybe a sequence of bits and positions. Is this something being considered as a technique to? So I'm just thinking loudly here, or maybe this can be taken offline, but.
Yeah, I think maybe we can talk later about that because, yeah, we need to move on. Thank you for your suggestions. Okay, so PML was great, except, well, first of all, this last decade, people were not happy with using XML anymore. They wanted JSON. And also another problem with PML was that if some feature or model is not yet supported by PML, because PML kind of describes each model, each transformation, each model feature. And if your model is new and is not yet described by PML, then you have to wait long time to get it added into the standard, because as I mentioned, it's moving slow. Well, lately, even slower than before. This guy, Jim Pivarsky, was working for Bob Grossman, and he was asked to create this new standard, which is JSON-based and does not have this problem that PML has. And so he created this portable format for analytics. He worked with a few other guys, I think. So it's based on JSON, and there are Avro schemas for data types. So basically, it's a mini functional math language. So in schema. So basically, instead of describing a model, it is representing the scoring procedure for you. So it's very different from PML. And you can find the description at dng.org/PFA. And here is a little example from Nick. I will show you Nick on the next slide. This is a little example of part of this PFA code for a logistic regression model. So you see, it describes here inputs and outputs in the JSON form or Avro schemas, and then it has actions. So you apply actions to the inputs to get outputs. So I'm not a very big expert on PFA myself. I wanted to get deeper into it, but then didn't happen. And there are several open source packages dealing with PFA. Hadrian was the original library created by Jim Pivarsky and his team. It has some PFA export and a scoring engine, and it hasn't been updated for at least like 3 or 4 or 5 years. And then my colleague Nick Pentres, he is in South Africa. He created this package called ArtFark, which is PFA export for SparkML. And he also gave many presentations about PFA and other related stuff. He's a great guy. And we did a presentation together at the last Open Source Summit, which was virtual. And then there is a package or several packages called Woken, which was created by Ludovic Claude, who is working at TÜV in Switzerland. And I will talk a little more about it soon. And then there is another package called this Transmogrify, which is PFA scoring for SparkML using ArcFark. And here is Ludovic in Switzerland. And he works with Human Brain Project. And they work with this network of hospitals in Europe. And in each hospital, they have data from patients. But of course, due to these privacy considerations, they cannot just exchange the data between hospitals or send the data somewhere else. So they build separate models in each hospital, and then they use PFA to exchange those models, validate, and deploy them. So it's a practical, real-life application of PFA. And we had a joint poster with Ludovic and Nick at a conference in Switzerland, which was in January of 2019. I have that poster somewhere in PDF format. Okay, so that's all I have about PFA. Any questions about PFA? No? Well, I do know that
that last thing about the Brain Project caught my attention. What was it about PFA that was enabling in that situation? I kind of missed that point.
Okay, I think maybe PML would also work, but he chose PFA. So this is a diagram that Ludovic created for our joint poster. So he told me that he works with Scala mostly, and I guess he was just using this ArcFark project to export the models in PFA, and working with Spark. I guess that was more convenient for them. But I think PML could work as well.
Maybe I didn't answer your question, Martin, but I was wondering, does PFA have any like confidentiality features, or I think that's what you're trying to do, right? You're trying to share data across different hospitals without really sharing any confidential information.
Well, you see, if you already built a model on the data, well, unless it's nearest neighbor model, you don't get the actual data in the model anymore. So if you just exchange the models, then it's okay.
Got it.
There is no privacy concerns.
As long as you cannot reverse engineer it, right? Or
I don't think you can reverse engineer if you use 100 patients' data to build I don't know, regression model.
Got it, yeah.
How can you reverse engineer? Yeah.
Okay.
So okay. Well, I'm sorry. I think I'm taking too long. So let's move on. The last standard I wanted to talk about was Onyx. Unfortunately, both PML and PFA were too slow to react to this deep learning revolution that happened in the last decade, less than decade, right? And PyTorch, for example, was great to build models, but then there was no deployment mechanism for it. And originally, Facebook and worked with Microsoft to create this open neural network exchange, Onyx, and to represent deep learning models, and so that they could export them from PyTorch and then deploy into Caffe or Caffe 2 maybe. And of course, in general, deep learning, as you know, there were so many different deep learning frameworks, and people wanted to be able to exchange models between different frameworks. But if you just create translators from each one to another one, you get n² possible translators. And if you have a single intermediate representation, that helps a lot. Instead of n², you get just O(n) of those. In addition, the hardware manufacturers also, rather than optimizing the code for all of those frameworks, they could just optimize it for one intermediate representation. That was very helpful as well. And so there is a lot of interest in Onyx. So it was only released in September 2017, but now there are so many. Here you can see some of the companies working on it, probably not full list because more and more people and companies are joining. And so originally it was for deep learning, then some traditional machine learning support was also added. Well, my personal opinion is that for traditional machine learning, PML is still much more rich than Onyx, but well, at least Microsoft thinks that it's good enough. And more recently, Onyx was accepted into Linux Foundation, AI Foundation as a graduate project, which is very nice. And it ensures good governance, etc. And there are periodic meetings of people working on Onyx. The last one was in April, and it was virtual. So it was supposed to be hosted by IBM. And originally it was planned to be in person, but then, as you know, things closed up. And so it was virtual. And it was in April of 2020. And Harry Kim, who represents Intel, he is one of the, so there is a steering committee with 5 people. Harry Kim is one of them. And he presented this slide about the growth of Onyx project from the meeting in March 2019 to the meeting in April 2020. And you can see that there is a lot of growth. So there are so many GitHub, more than 8,000 GitHub stars, and there is a Onyx model Zoo, which I think since then has grown much more, etc. And there are many published papers and many people working on it. And how does it represent things in Onyx? Well, there is this Onyx graph, which is some directed acyclic graph, and it has operations, and each tensor has a name, and so this is a representation, text representation of some of that graph. Actually, Onyx is using a binary protobuf format, and so the single Onyx file would have all the graph information plus all the tensors, so it would be a single file that has all that is needed for scoring. And it supports many deep learning frameworks. And there is also this part called OnyxML that supports some of the traditional machine learning. But again, in my opinion, it's not as good as PML, but well, apparently good enough for whatever they needed. At Microsoft, I know that at Microsoft they use Onyx very widely. Microsoft is very, very active in Onyx project, and they are using Onyx widely to exchange models between all the different products that include analytics, and it works very well for them and has very good performance. So they also created Onyx Runtime, which is a separate open source library that does the Onyx scoring and does it very efficiently. So this is the Onyx ecosystem. There are converters from many frameworks into Onyx. And then there is also Onyx Model Zoo, which are a set of open source pre-trained models represented in Onyx, and there is good documentation for them. And then once you have an Onyx model, you can run it through Onyx Runtime, or you can also use those visualizers to visualize the models. But you don't, of course, see all the details of the model in visualizer, but at least some of parts of the graph you can see. And in terms of the future directions for Onyx, so there are ways to improve OnyxML. Actually, I'm leading this training working group, Onyx training. So the idea is that now we want to represent not just the models which have been trained already and just need to be used for inference, but also keep all the training information in the model so that training could be continued in a different framework or in ONNX runtime. And recently I saw a paper that said that somehow they accelerated working with some of those transformer models using ONNX runtime, and it worked very well. Anyway, yeah, so there are many open issues, definitely. So even though there are hundreds of people working on it, there are many open issues that still need to be worked on. And recently also I saw this publication that now ONNX runtime can work on JSON Nano. You know, JSON Nano is one of those little things. So that's very nice. And in terms of model zoo, yeah, there are many models, many different kinds of models, including object detection and segmentation. And you can see on this website all those models. And they are open to adding more models. So if you want to contribute, you could. Well, okay. Any questions about ONNX so far?
Yeah, feel free to unmute yourself if you have a question for Svetlana. So if I understood correctly from this slide, does it mean that ONNX has solution for the original problem that you posed for PMML, for the object detection and segmentation challenge?
Right. Yeah. Yeah. ONNX definitely has everything. Well, I think most of the things figured out for convolutional neural networks. Yeah. So it is true that I should just go and see how they do this. I just hadn't had a chance. So busy.
I didn't mean to cut off somebody. If you have questions, go ahead. Unmute yourself.
Is all the models in the ONNX models who are free, or some of them are for free?
They are all free, yes. Yeah, so you can go and get any model and use it however you want, I think. Yeah.
On the chat, Truba is asking, is ONNX only for neural networks, or does it support other model architectures as well?
Yeah, yes. So there is this part called ONNX ML that supports other models as well. At least they support most of the SKLearn.
Got it. Thank you.
Thank you. And they also support, I think, those ensembles. So I find some things very strange. For example, you know, in PML we have ensemble. You can have ensemble of anything. In ONNX they only allow you ensembles of trees. Well, I guess that's what most people use in practice. But what if I want to have an ensemble of neural networks? I don't know if ONNX allows that.
Is PMML also have a model zoo, or anybody thinking about it?
PMML has some example models. You see the difference, I think, between deep learning and traditional machine learning is, okay, with deep learning, you can have this model that recognizes dogs versus cats, and you can publish it, right? With traditional machine learning, usually you build a model which is pretty specific for whatever data you have. And I don't think it would apply very well to some other situation.
Unless, well, I guess natural language processing.
Yeah, with PML, you cannot really have natural language processing.
Okay, I see.
It's just structured data, regular structured data. But we do have example PMLs posted on the DMG website. There are some examples, definitely. But I don't think they are very useful other than just as examples of how you represent those models. With deep learning, it's kind of, you know, more general things that you can apply. Although I guess in practice, for specific things, you need more specific models too. Yeah, probably you cannot use this cat versus dog model for any practical application. in industry somewhere, right?
Yeah, in cybersecurity domain, there is an advantage of sharing models, because if you have a detector for a specific attack, and usually the cybersecurity data is structured and can easily be like a packet. Fields are well known.
Mm-hmm.
Host message logs are kind of we have limited number ordering system, and it's probably can be potentially an area where model sharing can be useful, because there is a lot of attacks, and attacker collaborate, defenders do not yet.
Yeah, well, I don't know, if you post your defense mechanism online, then everybody will see how to find holes in this, right?
Possibly, yes, but maybe you can create industry coalitions where trusted partners can do that.
Okay. Okay. Sounds good to me. I don't know much about security, unfortunately. It seems very interesting area. Okay, so if we still have a little bit more time, I wanted to talk briefly about some open source libraries. Okay?
Yeah, go ahead.
Okay. Yeah, so a few libraries related to those standards that I just described. And the first is JPML. So this is Vilu Rusman in Tartu, Estonia. And there are 38 repositories. And most of them are in Java. Well, there are a few in Python and R that provide the conversion of those models, SKLearn and R models, into PML. And as I mentioned, the JPML scoring actually is not free. So, I mean, it is open source. You can see the code, but if you want to use it in commercial product, you have to contact him and probably pay something to use it. And then, yeah, it also, this is a list of packages and products for which JPML claims to support PMML. In particular, it supports PML exported from SPSS and SAS and many other places. And then the open source package for scoring is PML4S. And as I mentioned, there was also PyPML, which is Python wrapper for it. But this is in Scala. And it's pretty easy to use it, apparently. So you just you load the model, and then you call the method predict, and you specify your inputs in one of several ways. There are different ways you can represent your input record, and you get your predictions. So that's pretty convenient. And then Hadrian, as I mentioned, was this original product for original library for PFA, which unfortunately hasn't been updated for a few years. But it is convenient because it could be used as standalone, or it could be integrated into products or websites in MapReduce. So pretty powerful library. And ArtFark is this package from Nick Pentrias. And here we can see example code of how to export PFA from SparkML. So you create, you load this, you load necessary libraries, and you create this pipeline that includes your stages. So the scalar and logistic regression, and then you just say to PFA, and it produces your PFA. And then Onyx runtime. Okay, sorry, I didn't update that slide because I was working on my presentation for this JConf, which is an upcoming Java conference which will be on September 30th. It was supposed to be in Chicago, but now it's online, of course. I had to record the presentation. Oh, Mary is one of the co-organizers for this conference. And for that, I was doing JVM-based libraries for model deployment. And so that's why I have Java API. But Onyx runtime by itself is a very powerful library, and it's very well optimized, and it's very good to work with it. Okay, so in conclusion, open standards enable easy machine learning model and pipeline exchange and deployment. And there are many open source libraries for working with them. And if you want to contribute to open source, there are many great projects to work with. And so here are some of the links I showed earlier, and you can follow me on Twitter if you want. And any other questions?
Yeah, feel free to unmute yourself or type your questions in the chat. Chris had a question about how prevalent is this mixed environment where you need this kind of interchange format. So you mentioned Microsoft that they're very active, Svetlana. I guess this question is how prevalent is this mixed environment in today's world where you have legacy systems or modern systems and you need this kind of intermediate interchange format?
Yes, I think it actually is a pretty common problem. I see a lot mentioned about it, because you see very often if you have a big company, there is a team of data scientists who are developing models, but then so they are using probably Python or some other tool, but then in production they may need a different programming language, different environment. So I think it is at some conference, I remember I gave one of the first presentations, I think it was like 2 years ago, in Vermont Code Camp, and one person came up to me and said, oh, you know what, we had such big problem with deploying models, we just had to rebuild the model every time we need to do a scoring. So, and somewhere I saw this, or somebody said this, that like 90% of the models never get deployed because I don't know how true that is, but I think it is a problem. Well, now there is this term called ML Ops. I don't know if you've heard. Now there are conferences about ML Ops. Basically, that's machine learning ops, like DevOps, you know, about how you deploy just the code into production, but ML Ops about how you deploy those machine learning pipelines into production. It is a problem that often is encountered, and it's not surprising that there are hundreds of people working on Onyx now. We have to have a reason to do that.
One more question from the chat. Chuba is asking about the federated learning example that you shared with us with the hospital sharing models and also complying to security restrictions. Given that the models will be running on different devices, does that impact anything in your representation, or where does hardware come into the picture when you use such open source models?
I don't think hardware comes into pictures. I'm trying to remember if in PFA they have something about like multi-threading, or with Onyx, I think there is some direction where they are trying to figure out how to optimize the models for like GPU. I'm not sure right now. That's a good question. Maybe I should look into that some more.
Yeah, and I'm also not sure I'm conveying Chuba's questions well. If anybody understood the question better on chat, please feel free to ask it. Cool. Any more questions for Svetlana?
Svetlana, I have a question. This is Yefim.
Hi, Yefim. How are you?
Hello. I'm good. How are you? Besides Microsoft, what other large companies are building runtimes for scoring ONNX? And related to that, which database vendors are building scoring engines for running ONNX inside databases to reduce data movement, so to speak?
Excellent questions. I don't think, well, I think ONNX runtime is kind of accepted by most people as their runtime. I'm not sure if there are other people building runtimes. I may be wrong.
So the runtime is effectively the Microsoft runtime that you mentioned, right? That's open sourced and no alternatives are available. Okay.
Well, I cannot 100% guarantee that there are no alternatives. For example, I remember, people from Intel were saying that well, you see, there are some converters from ONNX into frameworks. For example, I should have said that. At IBM, actually, there is a team that is converting ONNX into LLVM. Okay. At IBM Research, they are working. Well, first of all, they started creating the converter from ONNX to TensorFlow, because you know TensorFlow has its own runtimes that you can deploy. Qin Huang is leading the converter from ONNX to TensorFlow, and then there is a team in IBM Research who are doing this LLVM stuff, and I think LLVM is, if I understand correctly, that's kind of executable, right? So, and at Intel, they have their own system. I forgot what it was called. So they convert ONNX into their own system, and then they run that. So there are other ways to run ONNX models. I don't know about in databases, because you see, deep learning is, well, it could be used with structured data, but I think more often it is used with images or.
Right, so databases can have images with driver's licenses and other pictures. You know, similar to the way Netezza and Microsoft SQL Server and others have been supporting PMML scoring.
Okay. Yeah, so there are different ways to do that, yes.
And the other performance-related question, you mentioned that ONNX supports traditional machine learning models. If a customer were to convert, export a model in ONNX format, traditional machine learning model, and score using PMML scoring engine versus ONNX, would there be any performance difference or no? How are they performance-wise, so to speak? Would there benefit for customers, say, to convert their PMML models into ONNX ML models?
Yeah, excellent question, Ify. I don't know that, but at some point I suggested that maybe we need to create this converter from PML to ONNX. But I think to create that, we need to add a few new features into ONNX, because as I said, ONNX ML I think is not as good as a PML. In particular, for example, with map values in PML, you can map any value string or numeric to any other value string or numeric. But with ONNX, there is this operator, mapping operator, that you can only either map numeric values to strings or strings to numeric, but not numeric to numeric or string to string, which I think is very strange.
I have a question regarding the few questions came about the execution speed of scoring.
Sorry, about what?
There was a couple of questions regarding how fast is the scoring with regard to ONNX versus PMML, but my understanding, at least, that the scoring is a function of the compute resources you have, the basically intermediate language that describe the model should not impact the scoring speed. Is this correct?
Well, I think many things affect scoring. In particular, for PFA scoring, I remember that Nick did some comparisons and he found that this Hadrian scoring was kind of slower than other kinds of scoring. For PML, there are different scoring engines, and I suspect they may have different speed. So it depends. And then the same model, I think, theoretically could be represented in different ways. Maybe you could intentionally make it more complicated than it needs to be. Then I would think that unless there is some kind of optimizer in the scoring engine, then it will be slower. So it may also depend on how efficiently you represent your model in whatever standard you're using. I think with Onyx there is optimizer, and in Onyx itself, maybe there is also optimizer in Onyx runtime, I'm not sure.
Yeah, the representation definitely can affect it if you poorly represent the model. But the engine, obviously, engine comes back to the implementation itself, how you implement the model. So if you don't have a good engine, that is a function of the engine implementation itself.
Yeah, definitely.
And obviously, if you run it in the cloud with a lot of resources, that will help you a lot versus, and in that case, you can even live with bad representation because you have a lot of compute resources.
Mm-hmm. Yes.
So if I may follow up on a point that we touched. So for customers, for like large companies that have been doing machine learning, say for 20, 30 years, and they have a lot of legacy PMML, so to speak, do they have a path, efficient path or any path to go from, say, PMML models into new Onyx environment, or they literally have to either redo it or maintain multiple infrastructures?
To my knowledge, there is not currently no converter from PML to Onyx. Maybe somebody did it, I don't know. But then, are you sure that they would have many old models? Because I would think that you need to update models anyway.
So they would need to export into a new environment and rewrite some of the code, right? Like I worked with some customers, they had several hundred models for different applications. So that means they would have to redo them and rehost them. So I'm trying to figure out, like, if you have one or two, that's one thing, but if you have hundreds of them, that's something else.
Yeah, then maybe somebody needs to implement this conversion. But then first you have to check if Onyx provides all the necessary tools for that. Or maybe new features need to be added to Onyx. Adding features to Onyx is kind of easier than to PML, because with PML we had very long delays with releases. With Onyx there are releases every 3, 4, 5 months. So it's a little faster. I don't know about Onyx runtime, how often they release things, but yeah, that's an interesting question.
Any more questions for Svetlana before we wrap up?
Cool. I have a question. Sorry.
Yeah, go.
Do we have somebody who has open positions?
We have a opportunity channel on our Slack. I think there are some positions there, but yeah, I'm curious to hear if anybody's hiring in our group. Feel free to unmute yourself and describe a little bit about what you're looking for. I'll redirect us again to our opportunities channel on Slack. We have some posts there. Any more
Okay.
questions from anyone?
Thank you so much.
Cool. Thank you, Svetlana. Thank you so much. This was an interesting session. Thank you everyone for joining, and let me share my screen before we say goodbye. Share screen. So yeah, thank you again. It's always interesting when two communities come along. I just wanted to say a few things. We have one more speaker coming up next week. Actually, let's start with that. It's related to legal AI and ML. It's a team from Canada. They're building this platform that will help with litigation with legal documents. And if that's something that you're interested in, there, please join us next week. It'll be an interesting session. And after that, we're probably going to take a break. We usually do that after each session. And after that, we'll tackle our next adventure. So we've done a specialization on TensorFlow. We've done coding examples. We've done a few sessions on guest speakers like today. But after that, we're going to tackle some other challenges and some new adventures. Specifically, we're going to take this quick mini course from Kaggle. It covers a little bit of different topics on data science in general, not just deep learning. It has machine learning, data visualization, feature engineering, deep learning, SQL as well. So if you're new to data science, or if this is something that you're interested in, please join us in a couple of weeks. We'll start that, and if you like to, you can also start ahead so you have a jump start when we get there. Then later on, I was really impressed by some of the notebooks that we put together, especially for the structured data set as well as the time series data set, and how machine learning models compare to deep learning models. So Dimitri, Robert, David, and I will put together some resources on some regression problems and decision trees in random forest, both from the theoretical perspective, but also from hands-on coding. And I have links here as well. And after that, if you join us, if you've joined our meetup a while ago, you know that we enjoy taking specialization from Coursera, especially from Lawrence and deep learning AI. So next we'll be tackling data and deployment specialization. This covers both deployment on the cloud as well as deployment on edge devices. So if this is something that you're interested in, join us for that specialization, or you can also take it in advance so that you have a head start as well. You need to freshen up a little bit your JavaScript for this, not just your Python skills, so keep that in mind. Probably after that, and making sure that we take the necessary breaks to absorb all this information, we're probably going to tackle the latest specialization from Coursera on NLP. The last course of the specialization covers attention models and transformer models like BERT that you've seen recently. As well as one of the authors of the original attentional unit paper, Lucas, who is teaching this course as well. After that, if we still have the energy and the courage, and the motivation to keep going, I'm a big fan of this book. I haven't read it yet. I recently bought it from Aurel Giron. He was on the YouTube team on the recommendation system. It's a book on machine learning as well as deep learning on SKLearn and TensorFlow. So it has two parts. The first part covers the machine learning part and decision trees, random forest, dimensionality reduction, and all that. Then after that, it takes a deeper dive into deep learning, things that we've seen already, but maybe from another perspective, as well as pre-processing data, convolutional neural networks, recurrent neural networks, GANs, generative adversarial networks, as well as reinforcement learning. That's an interesting topic to discuss as well. So this is our time frame. If any of this is interesting to you, please join us. And we're always looking for volunteers. So if you love to lead a session on any of these topics, you don't have to be an expert. As you've seen, none of us is really an expert. We're always continuously learning something new. So if this is something that you're interested in, please feel free to join us. We really need the community to support each other so that we can successfully do this over time. Having said that, let me monitor the chat, make sure there's a lot of thank you for you, Svetlana, and thank you for a great presentation. Thank you everyone for coming. With that said, I will stop the recording here, and I'll see you next week. Both the slides and the recording will be posted on the meetup page as well as on our YouTube playlist. And with that said, thank you everyone for joining us, and welcome again if this is your first time.
Thank you.
Thank you. Thank you.
Thank you. Thank you, everyone.
Thank you. Have a great night and a great evening.
Have a nice weekend.
Have a nice weekend.
Nice to meet you. Goodbye, guys.
Nice to meet you.
Bye-bye.